Okay, good afternoon. So I contacted the examiner. She didn't reply actually back to me. So I actually exactly don't know what to do. So let us do some mathematics together, which is somehow related to this course, and that is the topic of dual spaces. So yeah, I didn't know that you haven't studied that before, so I didn't present it in a good way. So let us do it in a structured way now. Okay. So I want to introduce some notation. So let us say that we have two vector spaces, V and W. These are vector spaces. And both of them are defined on the same field F. In our course, F is either R or C, yes? But it is important that both of them are defined on the same field. And then I hope that you are familiar with this notation. This is the set of all possible linear maps from one of these vector spaces to the other one. So for example, if I want to define it, I define it as the set consisting of all maps from V to W, but not all of them, the linear ones. Okay? Something that you need to know, and please interrupt me if you have any questions. So, something you need to know, we start with vector spaces, and then we construct a new set consisting of all linear maps from one vector space to the other. And I want to give the structure of another vector space to this one by defining two operations: addition between functions and multiplication of a number by a function. And that is exactly how you define it in calculus. For example, if I want to add two functions together, we know how to define them in calculus. That's the same way we want to do here. So what is the definition of t plus s? T plus s is a function that when acts on v, it gives you t acting on v plus s acting on v. Okay? And if I have a number, so let me call my number lambda from my field, I multiply lambda by t, it becomes a new function. And if I ask you what is the role of this function, how does it apply on v, you will tell me that first t applies on v, it becomes an element of the target space, and then you multiply it by lambda. Okay, so it is very easy. I hope that you have already seen that. Have you seen that before, that this becomes a vector space on its own? Yes? But there is one special case that we are interested here. So any questions here? So L, V, and W is always a vector space if I define the addition like this, and if I define the scalar multiplication like this. But one question first, I want to try to warm you up a little bit. Do you think that the field itself can also be a vector space? Yes? So if every field is also a vector space on its own field, on the field, the same field as itself. So I can see that, okay, F is my field, but F itself can also be viewed as a vector space, can be viewed as a vector space over the field F. F, yes? So for example, what is the dimension of this field? And can you tell me a base for this field? What is the dimension of the field itself viewed as a field, as a vector space, sorry? It is 1. And what is the base, for example? One base? The identity element of the field itself, for example, this one. Yes, this will play the role of the field. Because here I have scalars, but the dimension of the field, if you view it as a vector space, is 1, and for example, any constant number except 0 can play the role of that basis. Yes, the basis for that. So this in principle means that I can go here, keep V the same, because when I started this, I told you that V and W are just two vector spaces over the same field. Okay, now let us keep V the same, but let me change W to F. So this notation still makes sense. Why? Because V is a vector space over F, and according to what I explained here, F itself is also a vector space over the same field. So this notation is a special case of this one. I hope that you understand that. Is that clear? Okay, so can you, for example, define it for me? What is the meaning of this if I want to write it in a more expanded way? It becomes what? If you don't mind, let me use Greek letters this time for denoting the elements of this. So I would say that this includes all psi's from where to where? From V to this one, to F, such that this psi is linear. So I hope that you see that I am not doing anything special. I'm just taking one particular case and write it here. This one is called the dual space. Yes, so the dual space of a vector space is just the set consisting of all linear maps from the vector space V itself, but to the field. So this means that when you want to understand the elements here, the elements are linear maps, but they take a vector from V and gives you a scalar back. So the output is just a scalar. Is that right? So this is called the dual space. And this expression here, even though I can still call it a linear map, but there are different names for this so that we can refer to it easily. So one thing is that we can call it a linear functional. And or I can call it, in your book they have called it linear form. Or sometimes we call it covectors. This is a better word, covector. So every element in the dual space, instead of just calling it linear function, we call it linear functional or linear form or covector. Any questions so far? Okay, so let me give you some examples of functionals. So let me write example. Examples of functionals. Just to get familiar, because if you don't see examples, it might seem a little bit abstract. So for example, let me take it very simple. Let me take my vector space to be R2, and let me take my field to be the same as R. So everyone knows that R2 is a vector space over that field. I don't know, for example, let me define a function phi from R2 to R like this. I don't know, 2x plus 2y. My question is that, do you think it's a functional? So my question, technically speaking, is that, do you believe that this phi belongs to this set or not? Which is actually, we can show it by the dual of R2. So the question is that, do you believe that this is true or not? First of all, it makes sense. You see, it goes from your vector space to your field. So I am respecting that. But do you think that this is indeed the case? Yes, because what is phi acting on is an element from my vector space, which is an ordered pair. And what it gives me back is a real number. So it takes me an ordered pair and gives me a number back. But can I immediately say that, oh, because of this, this is a functional? No, what should I check? if it is linear or not. Okay? And I don't think you have problems with linearity here. So for example, let me just do one of them. If I want to make sure that this is linear, what should I do? I need to, for example, calculate this and see that this is equal to phi acting on this plus phi acting on that. Okay? So in order to continue, I know how to add because these are two vectors in my vector field. So when I want to add them, according to the addition rule there, I add component-wise x1 plus x2 and y1 plus y2. Okay? And then how can I continue now? So this tells me that phi of x and y is 2 times the first component plus 3 times the second component. So this becomes 2 times the first component plus 3 times the second component. But you can immediately see that I can split them and I can write it as 2x1 plus 3y1, yes, together, and then plus 2x2 and 3y2 together. Yes? Is that right? And then if I ask you what is this one, hopefully you see that this is exactly phi acting on x1 and y1 plus this is phi acting on x2 and y2. Yes? And of course, you need to check the other one around, but I think this is very simple, so let's not waste our time, okay? So another thing I have to check is what? I have to convince myself that for every real number lambda, phi of lambda acting on this is equal to lambda phi of x and y, yes? And I hope that this is very simple for you to do that. You just multiply lambda here and use the rule and then factor lambda out, so that you have. This is a very functional. It's the simplest possible functional probability that you have. Yes? But let me give you a little bit of more example so that you can get familiar with the concept. Any questions so far? Okay. But now let us go, for example, to this one. Let me take V. So let me just be summarized because I know that we will not have time to complete everything today, might be. But so let me just summarize it. Let me write Pi from Rn to R. Okay? What is this I? I is any number that you like in this set. And then what do you expect? You expect that I give you how this acts on any element of Rn. But elements in Rn are n tuples. And I define it for you like this. If this index is I, you pick up the ith component. Yes? Have you seen this before? What is the name of this operation? It's taking an n tuple, x1 to xn, but picks up the ith element and gives it back to you. First of all, do you feel that this might be a functional? Yes? Because it goes from a vector space to R. Yes? And it is a single number because it is picking up one of these elements and giving it back to you. Okay, but this is called the projection operator. It projects this tuple on the xi axis. It picks that component for you. But of course, it is not guaranteed that this is still a functional. You have to check the linearity. But I am sure that linearity is so simple, so let us just keep it. So this is another example of a functional. Okay? Another example of a functional that might be interesting. So let me, for example, give you this. Let me write it psi. And I want to write from PR. Here, I don't know if your book is using this notation, but here I mean the set of all polynomials with real coefficients. Okay? So this acts, and I want to get a number back. So and I define it in this way. So psi acting on P gives me, for example, I don't know, 2 P prime of 2 plus 3 P double prime of 1. Yes? Do you think that this is a function? First of all, do you feel it is well defined? At least I am respecting my own rules, yes? This is a vector space. What is this vector space? Imagine all polynomials whose coefficients are real numbers and put them in this with the same operations of addition and a scalar multiplication for polynomials. It becomes a vector space, yes? what I am telling you is that this psi picks a polynomial from this set. I call it P. Imagine that a polynomial is picked now. That polynomial can be differentiated 1 time and 2 times. And then what I am doing, I am calculating the derivative of polynomial at 2. And here I am calculating the second derivative of my polynomial at 1. And then I am adding them up. First of all, do you agree that this is just a number? Yeah, so that's a number. Okay? But do you think it is also a functional? Is it a functional or not? First of all, is the definition make sense for you? Do you understand what's going on? Okay, but is it a functional or not? I want you to know, because you are supposed to be math majors, okay, so don't think, so polynomial, so everything about functions that are important, you see, people in calculus will say function f of x. Technically speaking, this is not correct. Yes, what is the difference between what is the correct way of saying the function? You shouldn't say the function f of x, you should say the function f with the rule f of x equals 2. But because usually we are lazy or with some convention, we just skip those. So you see, if I send x to this operator, which is a function, it gives me back something f of x. So f of x is not the function, it's the output of the function. The function is this apparatus itself. Okay, so when I talk about a polynomial, don't think that you have to write the polynomial in this way. This is the value of the polynomial calculated at x. So when you want to work with higher level mathematics, so in principle I shouldn't write p of x here. I have to write psi acts on p, but it gives me this derivative of the this polynomial calculated at 2, etc. So if you want, this is a correct notation. If you insist to put in x, you shouldn't put x here, because this is, what is this? P of x is not a polynomial, it's a number. It's the value of p calculated at x, and which is not here. Yes? So when I say this is not a good notation, if you insist to incorporate this x, you have to write x outside. Yes? So this is not a good way. So this is what I want you to understand. But tell me, do you think that this is functional or not? We have to check if it is if it is linear. For example, let us check one of them. So if I want to check, I need to give me 2 polynomials. I call them p and q, and I want to convince you that this is psi acting on p plus psi acting on q. Yes? But if I ask you what is psi of p plus q, what do you say? According to the rule, I have to multiply 2 by the first derivative of my polynomial calculated at 2. So what happens here? This becomes 2. What is a good way of writing? Can you tell me? Okay, say something. So I should write p plus q, because now this is my polynomial. Derivative calculated at 2. And then plus 3 times p plus q double prime calculated at 1. Is that understandable? Because if you don't write it like this, this is not correct technically speaking. But now you know that the derivative of a sum is equal to the sum of the derivatives. Why? Because differentiation is linear. So the linearity of this function is really dependent of the linearity of the derivative. Okay, so this is important to see. So I can write it as 2 p prime plus q prime acting on 2. And then plus 3 p double prime, I can do it 2 times, q double prime acting on 1. Okay? But one thing I want to do, I want to write it like this. Do you accept it from me or not? But I want you to feel that this is correct. Do you think that I really can put 2 here and here? What is it? Is it distribution, or based on what you are saying that this is allowed? I need a word. So that's why I'm asking these questions, because I have a lot of experience. People usually don't care about these things too much, but in mathematics it is extremely important. So it seems that I am distributing this 2 in, but of course, if I say this is distributed, you might say something, but deep in your heart you say that this is nonsense. Okay, this is not distribution. Yes? But so what is it then? Do you feel the problem? Because I want to flip 2 in. That is my goal. But I have to justify what I'm doing it. I am doing it based on I want to wait a little bit longer, because these are very important things if you want to learn mathematics deeply. This is the first of it. This is the last of it. Based on? Come on, guys. Have you played these games? Based on definition. Yes, I just told you, yes? When I said that what is the meaning of the sum between two functions, the definition of the sum of two functions is a function who acts like this. Do you agree or not? That was the definition of the addition of two functions. P prime and Q prime are polynomials. These are a special kind of functions. So I have the sum of two functions acting on 2. By definition, it is P prime 2 plus Q prime of 2. Do you feel it? Yes or no? Okay, that's good. So then I go to the next one. I hope that this is not mysterious anymore. So do you think that I can do the same thing with this? Yes? And then, can I split it? This is very simple algebra now. So let me put this here, and then the same thing here. Yes, Q prime. This dual space is the first time that you have to be very careful about your mathematics knowledge and how you use it. And now what can I write for this one? I can write it as psi p plus psi q. Do you agree with me or not? Okay, so that's, I haven't proven completely yet, but the next one is simple, so you can do it. But just tell me, for doing the next one, what is the next one? I want to convince you that if lambda is a real number, I can pull it out. Okay, I will also need one more definition. Which definition? It is still on the board somehow. Yes, if you understand what I say here. Which definition will be needed? Because what happens here? This becomes 2 times, what should I write correctly? Lambda p prime at 2 plus 3 times lambda p double prime at 1. Yes? But we learned about derivative that if this is a constant, I can pull the constant out and it becomes p prime. But then, the definition is still on the board. Number multiplied by a function acts like this. You apply the function first, it becomes something, then you multiply it by the number. So please do that part yourself. Okay, so that's very simple. Okay, let me give you another example. This example is a good one. So let me take V to be this. Are you familiar with this notation? Yes? What is it? This is the set of all continuous functions, continuous real-valued functions defined on the interval between 0 and 1. With the same operations of addition of two functions and multiplying a number by a function, you know this, hopefully, that this is also a vector space. Okay? So now let me define it in this way. So, psi, I define it from this C. It's better to write it like this. Of course, this is the correct notation, so let me not be lazy. And then to R. And then, so tell me, what do you expect me to write in the pair of brackets? Tell me. So I want to make sure that you really understand what's going on. Because you know what happens, psi should act from an element from here and gives you a number. Okay? So can you tell me what should I write here? What are the nature of elements here? Are they numbers? What are they?
Function.
They are functions. So what should I write here, for example? Help me. If, not f of x. Psi of f is equal to, now I want to define it for you, integral from 0 to 1 f. If you insist, I don't like to put dx here, because there is no x involved here. So this just tells you the integral of your f between 0 and 1. Do you think it's a linear function now? First of all, it makes sense, yes? This is chosen from here, and you know that if a function, by the way, is it well defined or not? Is it guaranteed that this is well defined? Why? There is a theorem. What's the theorem? Otherwise, this cannot be written even down. So in mathematics, you cannot even budge. You have to justify every step. If I want to say this is well defined, I have to make sure that the right-hand side does exist. Does it? Why? Say something, please. Yes. Because it is continuous. There is a theorem that if the function is continuous, it's also integrable. And if it is integrable, this integral exists. Yes? So it is well defined at least. But it is not guaranteed to be linear, but you can immediately realize it is also linear. For example, psi of this becomes what? Integral of 0 to 1 of f plus g. But you learned in very simple calculus that it can be written as this plus the integral of that. Yes, do you agree? And this becomes psi of f plus psi of g. Yeah? Okay. So I think, one more example from the world of matrices. Okay, so let me check. So let me define it for you. The set of all n by n matrices. This time let me take it complex, with the complex entries to complex numbers, and I define it for you as psi of a is equal to trace of a. Okay, is this a functional? First of all, it makes sense. As soon as I give you an n by n matrix, it is a square matrix, so it has a diagonal, and I can talk about the trace of that matrix. If it was m by n, it was ill-defined, yes, because trace is only meaningful for square matrices. So at least I am respecting those things. But is it functional? Yes. I have to check that, for example, this becomes the trace of a plus b. In the previous course, you learned that this becomes simply trace of a plus trace of b. And trace of a is psi of a, and trace of b is psi of b. And the other one is also very simple. Yes, I try to give you a diversity of examples from different fields that they are involving with functionals. Okay? So this motivates you, at least this concept might be important. Any questions? Okay. Now, before going to the main one, I will express it as a theorem, but this is, according to your examiner, they have chosen different problems from the book, which is the proof of this theorem. But this theorem is so important that I will express it as a theorem. But before doing that, let me do some recap from the previous course very quickly. So if I want to show, go back to your calculus course. If I give you two functions f and g, and I ask you to show me that these two functions are... No, let me do that. What do you do if you want to introduce me a function? What do you do? You want to tell me, Babak, I want to introduce you a function. Then, if both of us know mathematics well, I will be waiting for you for two things. What are those two things?
What it does.
What it does comes second. What it does on...
What you put in.
Yes, what you put in has a name in mathematics. What is the name? By the way, names are very important. You can call me ha ha ho ho ho, but in mathematics we cannot call these like that. Yes, you have to call the names. And they are extremely important. What is that name? What's the name? No, domain. The function, if you want to introduce me a function, you have to introduce me the domain and how it acts on the elements of the domain, which we usually say it is the rule of the function. Is that right? So, and then let us say that I want to define a function whose domain is real numbers. Okay? If I want to define a function for you whose domain is the real numbers, it is not usually enough to tell you how the function acts on a subset of R. Is that right? For example, if I say that f of x is equal to x squared if x is between 0 and 1, if you understand things good, you are still waiting for me to complete my sentence. Because on the one hand, I have told you that the domain is R, and on the other hand, when it comes to the rule, I am telling you that how f acts if x is between 0 and 1. So in principle, you should wait for me to tell you how it will act on other elements of the domain. Is that right? That's clear. The same is true for linear maps. Okay? So linear map is in the first place a function. So if I want to define a function, I have to respect the rules. Okay? So for example, if I want to define a linear function like this for you, by writing like this, I am telling you that the domain is this vector space. Yes? And in principle, I have to tell you how this T acts on every element of V one by one. Yes? For example, if I want to do the same thing, I would say that f of x is equal to x squared for all x in R. Something like this. Then you don't complain because I define the function for you completely. But when it comes to linear functions, even though still the same strategy works, but I have one nicer option. Instead of telling you how T acts on every element of V, I can do it a little bit better. What is that? So these are extremely important questions, yes? So if I want to define a function for you with R, with domain R, I have to tell you how f acts on every element in R. So with the same gesture, if I want to define for you T, in principle, I can define how T acts on every element of V. But if this is linear, there is a more efficient way for me to do it. What is that? These questions that I'm asking will actually fix the mindset. You should have these kinds of mindset. I can only tell you how T acts on an element of the basis. That's it. So if I know how T acts on a basis, I know everything I need to know about T as a whole. Is that right? This is not something that every function shares. Okay, so if I want to define for you, one way of defining it, for example, let us make it very simple, R2, R2. One way to define it is to tell you f of T acting on x and y, how does it act? For example, it gives me x and x plus y. No one criticized that this way. If I do it like this, you know everything you need to know about T because you know how T acts on every element of x and y. But in principle, I can pick up a basis for R2. For example, let me choose the standard basis. Yes? Let me call this one B1 and let me call this one B2. And then I can, instead of telling you how T acts on every element xy, I will, for example, tell you that T acting on 1 and 0, which is one of the elements in my basis, to be 1 and 1. And I tell you that T acting on 0 and 1 will give you 0 and 1. Okay? So if I provide you these two pieces of information, so how many pieces of information I am providing here? Can you tell me? How many pieces of information I'm providing for you? Infinitely many. Because I am telling you how T acts on every ordered pair x and y. So I am providing for you infinitely many pieces of information. But how many informations that I'm applying here for you? Only two pieces. I'm just telling you how T acts on 1 and 0, and I'm telling you how T acts on 0 and 1. And I am claiming that that is enough for understanding how T acts in the whole space, because it is linear. Is that right? So I hope that I haven't done, for example, how do you go from here to here? Because you say that, okay, you have given me these two informations, but you have also provided me a valuable piece of information, and that is linearity. So then I would say that I can do like this. Yes, everyone agrees? Because x and y can be written like this. And then because it is linear, I can split it. X and y are constants. So what is t of 1 and 0? You gave me, good. And what is t 0 and 1? You gave me 0 and 1 again. Yes? And then I multiply them, so it becomes x and x plus 0 and y. And then I add them up, and I get it. Okay? So remember, this is a very important one for what is coming. This is the mindset you need. In order to give you the whole piece of information, how t acts on the whole domain, if it is linear, I just need to tell you how it acts on the elements of one basis, no matter which basis I choose. Is that clear? So have this mindset. Let us go back again. Any questions here? Do you remember, if I want to show in calculus, in previous courses, if you want to show that two functions are equal, what do you say? How do you prove it to me? I give you two functions, and I ask you, are these two functions equal or not? What do you check to see if the functions are equal?
Integral of the absolute value difference.
No. These are techniques. I am talking about definitions. You might say that for this type of functions, I use the idea of absolute value. I'm talking in general. What is the definition of equality of two functions? It needs a definition, yes? Yes?
Marks the same things to the same results.
This is one condition. So for example, it's a typical one, might be you have seen that. F of x is equal to 1, and g of x is equal to x over x, and then h of x is equal to x squared plus 1 over x squared plus 1. Are these three functions equal? Yes? Are they equal or not? No, they are not equal. The first one and the last one are equal. But this one is not equal to this one is not equal to that one. Why? Because to functions to be equal, we have two conditions. The domains should be the same, and the function should act the same on the common domain. Yes? So if I ask you what is the domain of this function, what is the domain? Everyone, please. Yeah, you have to say something. What's the domain of this function?
X.
No, domain is a set. So domain is R. Domain is the set. Please tell me, because no worries, you know.
Why couldn't it be C?
What?
Why couldn't it be C?
C?
Yeah, like complex.
No, we are working. Yes, I'm bringing examples from real calculus. I'm making it simple. Yes. So this is R. Yes. I am talking about real calculus here. That if I didn't say that, that's sorry. But then what happens here? What is the domain here? This means that domain is the set of all possible values that you can put into your function, and its function makes sense. Is there any restriction for the values of x that I can put in here? No. This f doesn't care what you put here, it gives you 1. Yes, it's a constant function. So it means that I can choose any number that, like, for example, if I give you this function, what is f of 5? What is that? 1. If I give you, what is f of the square root of 2? That's 1 again, yes? So this function is a constant, so every number I can put in. What about this one? Is it possible to put any number that I like instead of x?
No.
Everything is okay with one exception. What's that exception? 0. So the domain here is what? Yes? So even though on the domain, on this domain, this function is 1 and this function is 1, but these two functions are not equal because the domains are different. Yes? So what about this one? What is the domain of this function? Whenever you want to think about the domain, think about the restrictions that you have for x. Is there any restriction for x here? No matter what x is, x squared plus 1 is always non-zero. So I don't have any problems. So the domain of h is also R. And what is the value of the function? Because everyone sees that these twos are cancelled and it becomes 1. So the domain is R and the values are always on the common domain equal. So I could say that the function f and h are equal, but f and g or g and h are not equal. Okay, so this is important. So the same true is for the function, for the linear maps. If I want to show that two linear maps are equal, tell me, what should I do? I need to check the domains. That is easy in linear algebra because you write it here when you write it. So if you see that these first ones are the same, you are relieved. Okay? And then about the rules. You can check that this is valid. For example, for this case, that I am in 2 dimensions, I need to check this one for all x and y's, but there is also an efficient way to do it. What is that efficient way? Instead of checking the equality of the rules for all values in the domain, I can check it only for a single base. Is that right? Okay. So now keep this in mind. And so you can have a rest for 5 minutes today. Okay. Now this is the theorem that I want to emphasize. Let me just write the theorem in a short way. So this is a theorem. In your book, the examiner, there are 2 exercises or a little bit more, I don't remember, that you are supposed to prove this theorem. Okay, so let me motivate you a little bit before writing the theorem. So I give you a vector space, and of course this vector space unfilled. And in your course, you are only dealing with finite dimensional vector space. Infinite dimensional vector space or Hilbert spaces, a little bit above your level of course, you have probably studied a little bit about Hilbert spaces, but not that much. So whenever I talk about a vector space, I mean a finite dimensional vector space. Okay? And then you have this field on which this vector space is defined. And because I am assuming that this is finite dimensional, let me introduce you, for example, a basis. I call basis and then I write it B1, B2, up to Bn. I am assuming that the dimension is n. Okay, so and this is one of the possible bases of this vector space. Okay. And then I told you that you can look at the dual space. This is a shorthand notation for what? According to what we started, is the set of all linear maps from V to F, which we call them functionals. Okay? So that is more or less what I added to the problem now, is that I have introduced you a basis for my vector space. Okay, but you have to have a question now. What is your question? If you are a good mathematician, at this point, you need what to do. So you should have a question. And that is how mathematicians actually make mathematics. They ask questions, they try to answer the question. So you should ask a question here. I will guide you a little bit. Just any questions do you have? So what is the next step then? Okay, I introduce you a bunch of examples, then what? Nice. Any kind of questions, any kind of research project? That question was actually a research project at some time. People answered that. Yes? So, well, what was that? That's the question. Especially I am talking about B. So, do you remember, this is called the dual space. Yes? If I ask you what is the structure of dual space in mathematics, give me a word, what do you say? What is the structure of V? Give me a name. What is V? Vector space. Yes? It's vector space. Yes? Don't try. And then what is this one? We talked about that. The structure of V star is also a vector space. Is that right? Am I guiding you towards something, towards the next question?
What the basis for?
Very good. So you see, you learn what to ask. And that's what the mathematicians actually do, yes? Because you know that what is the most related concept to every vector space is its basis. And then I introduce you a new vector space. if you have the right mindset, you would immediately ask, okay, can I find this basis for this new one? If you give me this vector space, and if you give me one of the bases of this vector space, is there any way for me to find a basis for this new vector space, which is constructed from the old one? So is that question now natural or not? So that is why when you see the next theorem, it is not surprising. You are expecting it to come. Is that clear? Okay. So now let us write the theorem. Let V be a finite, let me write be an n-dimensional vector space with B1 up to Bn be so let V be an n-dimensional vector space with B a basis of V. The set, I call it by B star. The set B star phi 1, phi 2 up to phi n, where, okay, I don't want to write the theorem, I want to help me. Okay, I want to introduce a basis for V star. For some natural reason I am calling it B star. It's not a bad notation, yes? V star, B star. But then I put some elements here. So, one thing that I want to ask you, the elements of these are vectors coming from V. If this is going to play the role of the basis for V star, what are these things inside? Are they vectors? Of course they are vectors, but we know more. What are they?
Functionals.
Functionals. Is that right? Because elements of the basis should come from its vector space. So if I want to introduce you a basis for this, the elements of my basis should be picked up from this vector space itself. But the elements of the vector space are not just simple vectors, they are functions. So I have to put functions in this bag and introduce it as a basis. The second thing, the question that you might immediately ask is the index. The index that I put here is n, and I am choosing the same index there. It is not trivial. So what I am implying before even writing the theorem, what I'm implying?
That they have the same
Dimensions. Okay, which is not trivial, but that is also part of the theorem. So if I can convince you that this one that I am going to introduce is a basis, I am also telling you that the dimensions are exactly the same. So the set B star, where for every let me write I in the set 1 up to n, phi I goes from V to F, and then phi I acting on Bj is delta Ij, is a basis for V star. So I am claiming something, then I have to prove it for you. So don't worry, it might be you don't know what delta Ij is, I will explain. But this first line of it shouldn't be surprising for you, yes? Because phi's are from my dual space, and you know that elements of my dual space are functions. So you shouldn't get surprised, oh, what is you are writing here? No, phi I for every I in this range is a functional. And then I have to tell you how it acts. Do you remember? Because if phi I is a functional, do I need to tell you how it acts on all elements of V or not? Do you remember I told you there is a better, efficient way to do it. Instead of telling you how phi acts on every element of V, I decided to tell you how phi I acts for every element of one basis of V. That is the same. I hope that I could convince you before. So that's why I was making that mindset, because of that theory. Yes, is that clear? Okay. But this is very, very handy notation. This is called Kronecker delta. So what is the definition of Kronecker delta? Semicolon equals 2 means defined to be what? If these indices are the same, it is 1. If these indices are not the same, it is 0. So instead of splitting it every time to say if it is equal, this is 1, if it is not equal, this is 0, we just write delta ij, you understand what I mean. Is that clear? Okay. So we have a claim. A basis is given to me. I am introducing you a bunch of functionals with this definition. And I am claiming that this will be one of the bases of this space. Okay? But now, proof. Proof has 2 problems in your book, which the examiner told me to do. So, but I don't want to prove it. You tell me what to do. What do you think? You want to prove this. You need to go back to your toolbox. Toolbox means your head, yes? Look around. What do you see in your head? You want to, this is an important question. What you need to show in order to prove your claim. So what do you remember from the previous course? What you need to remember from the previous course? You need to ask one question. I want to show that a collection of vectors is a basis. You need to learn how to not let you be distracted by the details. The core, if a set of functions, a set of vectors are given, you want to show that this set of vectors are form a basis. Yes? So what you need to remember from previous course? How many things I have to convince myself about in order to guarantee that this is indeed the case? 2. So 1,
Linearly and independent.
I should prove for you that they are linearly independent. Second one?
Span.
A span. Yes, I have to show that this will span every all the V star. So I need to write this one. A span of phi 1 up to phi n is equal to V star. 1 question mark. The second question mark is that V star is linearly, let me write it, it's too long, linearly independent. Okay, so might be this one is easier. If you don't mind, let me start with 1 and 2. Okay, so tell me, I want to show that this is linearly independent. So what do you think we should do? Again, you see I am doing it the same thing. I have trained myself to do this very quickly. So when I want to do this, again, I go back to my toolbox. What I need to do to show that this is linearly independent. If you don't remember the definition precisely, there is no hope for you to go on. So what is the definition of linear independence precisely? Yes, please.
The sum of all vectors should only be 0 if all coefficients are 0.
Not the sum, the linear combination. You said
Yeah.
sum. Sum means
Yeah, but
the linear combinations, the coefficients should be 1. When you say the sum, you mean V1 plus V2 plus etc.
okay.
Yes, but what you are saying is correct. So in order to do that, I would say that I would write lambda 1, for example, phi 1 plus lambda n, phi n, okay, equals to 0. I myself put it equal to 0 and ask myself, do you think that this implies that all the constants are 0? Yes? If the answer to this implication is positive, then yes, they are linearly independent. But one question, You see a 0 here. I am just trying to not let you sleep, yes? This is 0, this is 0. Are they the same? No. What this 0 is what 0? Is the 0 of the field. For example, just 0. But what is this 0?
Zero function.
0 function. Very good. So you see, you are learning. So this is the 0 function. Why? Because when we add them up, it is equal to 0. What I am doing here, I am multiplying functions by constants and adding it together, so it becomes at the end a function. Yes? And when I put it equal to 0, I don't mean number 0, I mean the 0 function. You might say, what is the difference? There is a difference. 0 is just one single number, but what is the 0 function? So let me just emphasize that this is the 0 functional. So what is the 0 functional? Takes every element from the vector space to 0, which is this 0 now. Okay? So can you tell me how can I? Let us concentrate on one of them. So let me do like this. Let k belongs to 1 up to n. We show that lambda k is equal to 0. Yes? If I can show that to you, we are done. Because the same kind of argument that allows me to tell you lambda number k is 0, I will repeat it and will show you that all lambdas are 0, one by one. So if I can show you for an arbitrary k between 1 and n, lambda k is 0, I am done. Can you do it now? So concentrate. Pick one k from this set. In the beginning, you are allowed to choose any one that you like. But as soon as you choose it, it is fixed now until the end of the problem. Okay? So that's why I call it k. This is the correct mindset. Okay, so now tell me, do you have any idea how to prove that lambda number k is 0? So let me write some of them for you in front of your eyes, and you have time to think. My goal is to concentrate and prove this one is 0. Do you have any idea? I write something, you tell me is it true or false. And the reason I'm a little bit in a hurry because I want to finish at least to some extent. Do you agree that I can go from line above to line below? Yes? The right hand side, I told you this is a functional. So the functional acts on an element from the vector space V. One of those elements is B sub k. So this is meaningful. And what is the answer to this meaningful thing? Can you tell me? Because that is the 0 functional. 0 functional acting on any element, including B sub k, gives me 0. Yes? But now I ask you again, don't fall into the same trap twice, okay? Can I flip this B here, 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 here? If you say yes, then that is up to you to defend yourself and say why. Yes? Be brave. Can I flip this B1, this BK inside here, 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 and here? I asked these questions 15 minutes ago. Can I do that? Okay, based on what? Definition. Very good. Yes, you are learning. So we move this because this is a number multiplied by a function, so that's the sum of functions, and I have BK, so I can flip it in. And then you know that in principle I have to flip it in this way. Yes? And then of course, can I take this out and flip it like this? Again, yes, by definition. So let me just do it immediately. This is bk. And then up to phi n bk. But now, one more step. I want to ask you, what is this guy? Look here. Phi I acting on bj is delta ij. Yes, that was my definition, and I'm proving my claim. So can you tell me what is phi 1? No, this is not, sorry, this is bk, sorry. This is bk. It should be bk all the time. Sorry. Can you tell me what is this one?
0.
0. Because a phi I acting on something whose index is different from I is 0, and if the indices are the same, it is 1, based on my definition. So if I ask you what is this guy, you will tell me this is 0. Yes? What is this guy? 0. What is that guy? 0. What is that guy? 0. What is this guy? 1. Yes? So what is left? Anion. Is that clear? So this was a little bit, of course, the person who actually came up with this definition was smart, but just regenerating that one doesn't need to be that much smart. Okay, so this is this. But you might say, Babak, you just prove one of them is 0, but do you agree that I can do the same thing for every coefficient, because what I chose was an arbitrary k. It does not depend on which one I have chosen. Whatever you choose, by this analysis, I show you that this is 0. Yes? So I am done with the first one. Yes? But for the second one, what should I do? I want to show that this is also the case. So how should I do that? Again, you see how many times I am doing the same thing. I have to go to my toolbox, ask myself what is the meaning of this. In other words, what's the definition of what I have written? Okay, I have to remember the definition correctly, and then when I have it in mind, then I at least probably will be able to do it. So what is the definition? In order to do this, if I want to show that the span is V star, can you tell me what to do? Every one of you should have a feeling about a span. So how should I prove that that is a span? Yes, tell me.
The linear combination.
In mathematics, just do it very precisely. Tell me what to do.
Oh, that you should write that definition of.
So you need to tell me, when I want to show that the span of this is V star, I pick one element from here, so this should be picked. So it means that I would start with this sentence. Let phi belongs to a V star. This is very important. You see that when you read mathematics books, they write something like this. They say that they are not stupid, They are following the definition. So you want to show that this is the span of this is that one. It means that whatever I pick from V star, that thing can be written as a linear combination of them. So let me pick one of them. I am picking them, picking it, and let this. We show that, for example, what? We show that phi is a linear combination of the claimed ones. Let me take them alpha this time. Phi 1 plus alpha n phi n. But this is not mathematically correct. Can you complete my sentence? If you are doing a scratch paper work, that is good enough. But if you want to write an exam on an article or a book, what should I write? We show that phi is this. If I say full stop, you are not a good mathematician. So what should I write?
Has to be unique.
No. No, I mean grammatically it is not correct. Forget about the details, mathematical details. People will ask what are alpha? Alpha 1, alpha. You have to introduce the notation. So, okay, where so I can read it again. Let phi belongs to this. We show that phi is equal to this for scalars, for some scalars, alpha 1 up to alpha n in f. Something like this. Okay? Okay, so now I want you to feel what we are looking for. Can you tell me? So you see phi, I pretend that it is given to me. I take one of those phis, even though I really don't know what that phi is, but I picked it, so it is fixed now. Can you tell me what I am looking for to complete my proof? Because you know, phi is something I picked. I can pretend I know something about it. At least it's a fixed element from V star. And phi 1 up to phi n, I know everything about them because it is given in the body of the theorem. And then what is not known to me? These coefficients, alpha, so I don't know anything about them. It is usually not always easy to understand what alpha 1 and alpha n is. And by the way, you know that if you are genius and you can understand what alpha 1 and alpha n are, you can write it, I claim alphas are these numbers and here is my proof for them. And no one will ask you, how did you come up with those answers? But usually mathematicians are not doing like that. If they don't have any clue, they go to a scratch paper and try to convince themselves about how can I find these coefficients so that it works. Yes? Do you have any idea how can I do that? So for example, can you give me some kind of guess what alphas are? It's not that easy. Yes? But we can make it a little bit easier. Can you tell me, for example, let me write it here. And if you don't mind, let me use sigma. Are you comfortable with sigma? Yes? So I would write sigma and then I would write, alpha I, and then I would write phi I goes from 1 to n. Can you, using what you see, can you tell me how somehow I can come up with alpha I? And by the way, don't say alpha I because I have used alpha I here, so let me ask you about alpha j. But j is a number belonging to 1 up to n. Yes?
Is it the phi of bj?
Very good. Very good. So let us see why. So phi of bj, okay? This is a scratch paper, okay? Scratch paper. So I write this in that way and I ask myself how these alphas can be found. Your friend told that this is phi of bj, but let us see why. I apply phi on bj. First of all, what is it called? This is a function. What is on the right hand side is a function. If two functions are equal, then this function acting on bj by definition will give me exactly as this function acting on bj. Yes? That is based on definition of equality. Okay, you might not still see why this is good. Be patient. So what can I write for this one? Copy and paste. But what can I write about this one? Can I flip bj inside? Yes, yes, by definition. So it becomes sigma, I goes from 1 to n, alpha I, phi I, bj. Are you with me or not? Yes? Okay, but do I have problems here? No. You see, phi I bj is defined to be delta ij. So this becomes what? Sigma, this is delta ij. So this becomes sigma alpha I, phi I, delta ij. So, and I goes from 1 to n. Be careful, j is an index I chose, so it is fixed. But this I is not fixed, it is running from 1 to n. Can you feel what happens based on definition of delta? Because delta tells me if the indices become the same, it becomes 1. If the indices are not the same, it becomes 0. So from this sum, only how many terms will survive? One term. Which corresponds to which index for I? J. Is that right? So everyone agrees this is nothing except alpha j? Are you happy with that or not? Happy everyone? Yes? So this is alpha j. Okay, so I am done. I found alpha j. But do you feel that we have done something? It seems like a circular argument, yes? I want you to feel it. Yes, not because I'm saying it. Do you buy this argument when you read the text? So what I am claiming that whatever you choose from V star, all these numbers for you becomes clear. Do you agree with this argument? If you choose one particular phi from V star and you know it, do you also know these things? Yes or no? If you know phi, it means you know how phi acts on the vector space. So when you know how phi acts, it means all these things are known to you. So as soon as you pick a phi, this means all of them are known to you. Yes? And what was my unknown? My unknown was these coefficients. So if at the end of the day I say that the unknown is equal to this, do you buy it or not as an argument? Yes or no? Do you feel it? Yes. This is very important, by the way, because this is just playing around with these curly things, phi's, b's, and things like that. You need to understand what's going on. So here, I pick a phi. What does it mean? It means a person, my professor there wants to bother me. He picks one phi and gives it to me, okay? And tells me that, okay, Babak, go use this phi that I gave you, find these alphas. Yes? What I did, I took the phi from my professor and I did some calculation using my friend, and I realized that alpha j is phi of the professor acting on bj, and I go back to my professor, here is your alphas. Can he complain? Can she or he complain? No. Because he cannot complain, because he gave me phi and I'm giving back phi of b's. So that's it. So are you happy now? So what is meaning? So I'm lazy to write it down again, there is no time. So this, you can take it off and write the scratch paper yourself. So this means that if phi, so then if you want to be a mathematician, you can start claim and then prove the claim. But all of these claims have been done as scratch paper. Yes? So I can claim, let phi is claim is that alpha j is equal to phi bj. And then what I wrote here is the proof of this claim. And then you put it back. It's finished. Is that clear? So I am not talking about these particular theorems, but I want you to fix your mindset, because if you want to go up to master level in mathematics, you really need to be able to think around these lines. Okay, otherwise the courses become harder and harder. Okay. Any questions? Understandable? Okay, there is a name for it. If I give you a basis, I will give you an example, by the way. If I give you this basis, and according to what I told you, you construct this new basis, this basis is called the dual basis, corresponding the old basis. Yes? So if I change this basis, usually how many bases are there for a vector space? How many bases are there usually for a vector space? What? Infinitely. Yeah, for example, R2. This is R2. I rotate it as another basis, another basis, another. These are bases, yes? So there are infinitely many usually. Okay? So it means that when I change this basis to another basis, this will also be affected. But this one will be called the dual basis of this one. Is that clear? Everyone understands? Okay. But as a good math student, you need to understand by reading the texts and write this question. Something very interesting, by the way. Let me write it down for you here. So if I want to write one corollary, I am writing it correctly, yes. So corollary is an immediate consequence of the theorem that you proved, usually worth remembering. So the first thing that we remember is that the dimension of V star is equal to the dimension of V. I told you, I'm only talking about finite dimensional vector spaces. That's one thing. And that is very clear because that index was n, and I convinced you that n is enough even for that case. So the dimensions are the same. The dimension is the number of elements in one particular basis. Yes? The second thing is that if you give me a V in my vector space, you know that I can write this V as a linear combination of the elements of the basis. Do you agree? So I can write it lambda. So don't write it down because I want to clean it. Lambda 1 V1 plus up to lambda n Bn. That is not surprising. If B1 up to Bn is a basis, when I choose a vector in my vector space, it's a linear combination of the elements of the basis. Is that right? But in this proof, we learned something. We learned what are these. What are these? What was lambda 1? Can you tell me what is lambda 1 now? So this is what I wanted to prove, okay? So lambda 1 is phi 1 acting on V. And lambda n is phi n acting on V. It's a very, very interesting relation, you know? When you pick a vector from your vector space, from previous course, you already know that this is a linear combination of these elements, of the basis elements. That is not surprising, that's a previous course. But in general, you didn't know anything about these coefficients. But now we know what are these coefficients. These coefficients are elements of the dual basis acting on the same vector. Is that right? And that is why another one that we just learned here, if I pick a psi for you from, so let me choose a phi as I did before, from V star, we showed that phi can be written as a linear combination of the dual space. Don't write it down, I want to clean it. Yes? This is not surprising because I showed you that phi 1 up to phi n is a basis, and I have picked one element from my vector space, so it's a linear combination of the basis elements. But we learned more. What are these lambdas? Of course, these lambdas are the same as alphas. So instead of lambda 1, I can write something now. What can I write? What can I write? Alpha 1. So might be I should have written alpha 1 so that you are not confused. So what was alpha 1? Alpha 1 was phi acting on B1. Alpha 2 was phi acting on B2. So that's a very nice relation, you see? So phi acting on B1 up to phi acting on Bn. It's a very, very nice relation. So if you give me an element from the vector space, and if you have given me the dual space, the dual basis, the coefficients of linear combinations are these. And the other way around, if you give me a vector from the dual space, and I want to write this as a linear combination of my dual space, I have some coefficients here. But these coefficients are the action of this onto the basis of my vector space. So you can see the duality somehow. Yes? Do you have any questions here? Okay. So let us try to give another example. Now the example is, I want to give a concrete example. So it means that I give you a vector space and I give you a basis and I ask you find the dual basis for me. If you do that, you will learn it very good. Okay? So let me clean the board. Can I clean, which one do you prefer to clean this first? This one. Can you find me the dual basis of the standard basis of r to the power of 2? you know, you can think a little bit before I clean the board. So I give you this. What is the standard basis? The standard basis is 1, 0, 0, 1. Yes? This is the standard basis, so if you don't mind, let me use my notation, a little bit of sloppy notation. Now my question for you is, what is the dual space? The dual basis. Yeah, please think about it until I am cleaning the board. Also pause. Okay, I am waiting for you. Do you have any idea what to do? So first of all, is everything clear? R2, this is the standard basis. Do you agree that this is the basis for R2? Yes? This is the famous one. This is on the x-axis, this is on the y-axis, so that's the basis. And I want to find the dual basis. The definition of the dual basis is here. So if I want to make it very precise, I have to say that phi, how many phi's I have? 2. Because I have 2 here, I should have also 2 there. So I will have 2 phi's. Phi I. I is 1 and 2. Acting on Bj. J is also 1 and 2 because there are not more. And I know the definition is delta I and J. Okay? But so I need to find phi 1 first. Because I need to tell you what is phi 1, what is phi 2. So if I want to say what is phi 1, I can tell you how it acts on every element, or I can do a little bit better. I can tell you how it acts on the on the basis. So can you tell me what is phi 1 acting on B1? This should be what? 1. But that is not enough. To really understand what phi 1 is, I need to know how phi 1 acts on B1, and I need to know how phi 1 acts on B2. But this is according to what we learned.
0.
The indices are the same, this is 0. Okay? Is that right? But now I want to know my phi 1. Phi 1 is a functional from R2 to R. So if I want to know my functional, I have to answer this question to you. For every x and y from R2. Because when I want to know the function, I need to know how it acts on every element of that. So that is the question mark. So this is the analysis that you have to do in your head. So this is my question mark. So my question mark becomes equal to phi 1 of x and y. Everyone agrees I have to answer this question. But then these are the 2 pieces of information I have, and based on these 2 I want to answer this question. So what do you think I have to do? I have to somehow use these pieces of information. So can you tell me how? I would write phi 1. Can you fill up this gap for me in a related way? What do I write instead of x and y? I have to write it in a way that B1 and B2 become involved.
X times B1.
Very good. X times B1. Do you agree? Yeah. X times B1 is x and 0. Y times B2 is 0 and y. X and 0 plus 0 and y becomes x and y. But can I go further? Yes, because phi 1 is linear. So what can I write? I can write x phi 1 acting on B1 plus y phi 1 acting on B2. Can I go further? Yes. Phi 1 B1 is 1 plus phi 1 B2 is 0. So this becomes x. So if I ask you what is phi 1 is the functional that acts on R2 and gives you what? The first component. This is your first element in your dual space. Is that right? But what was the name of? We had this in my examples. Do you remember when I was giving you an example, I denoted by pi. So this is a projection onto the x-axis. So if my basis is the standard basis, the dual basis will be projection maps onto x-axis and y-axis. I didn't calculate that. I hope that you can do the other one yourself. But what is your guess? What will be your guess? It would be y. So this means that if I have the standard basis in my vector space, the dual space are projection operators. Is that clear? One more step that is a little bit harder. No, I mean harder, the idea is the same. So, let me write this one for you. The same story, V is R2. And then I give you a new basis, not that one was very simple. So I give you this basis, B1, which is 1 and 2, and B2, which is, I don't know, 2 and 3, and I ask you to find the dual basis. This is not trivial. You have to do some calculations, but that's very simple as well. But I hope that the structure of the question is clear. A vector space is given, a basis for that vector space is given, the dual basis is demanded. So, how should I think about the problem? For example, let us think about phi 1. So I know that there are two phi's involved again. So phi 1 on B1 is 1, phi 1 on B2 is 0. Yes? What should I answer to you for knowing phi 1? I need to tell you how phi 1 acts on x and y. Is that right? This is what I have to tell you, exactly as here. But what I did here was so simple because immediately, without any kind of calculation on paper, I realized that this ordered pair can be written in this form because it was so simple. Here, if you're smart, you can probably guess. Otherwise, you can calculate. We don't have to do that. Okay, so can you tell me what is the first thing I will do? I will start asking myself, how can I write x and y in terms of B1 and B2? So it means that I don't know alpha times B1, for example. I need to find alpha plus beta times B2. I don't know beta. But I pretend that x and y are given and I want to find alpha and beta in terms of x and y. Is that right? Okay, so what should I do? This means that x and y is equal to alpha times b1. So let me multiply alpha immediately inside. So it becomes alpha to alpha, beta inside. So this becomes alpha plus 2 beta and 2 alpha plus 2 beta. Do you agree? And it gives me a system. That is very important skill in mathematics. When there are a lot of parameters involved in the problem, you shouldn't get confused. What I am looking, how many unknowns I have in principle in this problem? How many unknowns I have? Of course, you see that there are alpha, beta, x, and y, four parameters, whatever. But how many unknowns are there? 2. What are those? Alpha and beta. So don't get confused. Pretend that x and y are given to you, and that's a high school problem. You need to find alpha and beta in terms of x and y. Do it in any way you like. For example, I would prefer to get rid of this alpha first. I multiply by minus 2 and add it here, so it becomes minus beta, and I multiply by minus sign, so it becomes 2x minus y. Yes? So y becomes 2x minus y, and then beta. And then I put it, for example, here. Alpha becomes x minus 2 this one. So it becomes 2. Am I right or not?
Yes.
Is that right?
Same like
Okay, but that's good. Because otherwise it would be highly unlikely that we do two mistakes at the same time. Okay, so that's alpha and beta. Do you have any problems here? Yes or no? So I'm just solving the system as if x and y are given. So I multiply this by minus 2. It becomes minus 2x. This becomes minus 2 alpha. This becomes minus 4 beta. When I add it here, it becomes minus beta. This is gone. This is minus 2x plus y. And I multiply by minus sign with this. Okay, so can you help me now finish the problem finally? So I go back here. So I would say that phi 1 of x and y is equal to. So what can I write for x and y now? It is alpha b1. Alpha is this guy. Yes, plus beta b2. So what happens? I can use linearity. This is a number, a scalar. I pull it out. Then phi 1 hits b1 plus that one is a scalar. I pull it out. Then phi 1 hits b2. Yes? So what is phi 1 b1 now? It is 1. What is phi 1 b2 is 0. So what will be the final answer? This is 1, this is 0, so 2y minus 3x survives. Yes? So we are done. So phi 1 is from R2 to R. Phi 1 acting on x and y is 2y minus 3x, which was not easy to guess. Yes? So this is the dual space. So at least hopefully the mystery of the dual space is gone from your head. So that is something useful for the future. But unfortunately the more interesting things were supposed to come, but we will not have time for it. The next step is to add inner product to your space. And it makes it very rich structure, especially for quantum mechanics. If you are interested in physics and you want to study quantum mechanics, that is very, very suitable for quantum mechanics. So after this, so this dual space, we want to add the inner product and then see that how this will help me to go back and forth between V and V star. That's a very interesting topic, but unfortunately we don't have time for it. I will upload this, of course, to my YouTube channel and TikTok channel. TikTok is also good, not bad. I have more interaction in TikTok than YouTube. Anyway. But of course, my videos are quite long. The limit on TikTok is 1 hour, yes? So I just go up to 1 hour and cut them, yes. Because I don't believe to these short videos. So if you have watched a lot of those short videos, your attention span is already ruined. But because you are under 25, I really recommend you to get rid of that as soon as possible. Yes. Okay, good luck then. Thank you very much. Thank you very much.